have practiced a bit more on systems of linear equations, we're going to apply these to word problems. So for the first question, we have that Kristen spends $131 on shirts. We know that fancy shirts cost $28, plain shirts cost $15, and she bought a total of 7. Then how many of each kind did she buy? We are going to write this in terms of a mathematical statement. And your first step is to define the variable. So we know we're talking about shirts. And there's 2 types. There are the fancy ones and the plain ones. So I'm going to let's say, X be the fancy shirts, or the number of them. Which means that Y can be the plain shirts, the number of plain shirts. Now we want to create an equation to determine how many of each kind does she buy. So we want to, in the end, figure out what X and Y are. On the very first part, it says that Kristen spent $131 on shirts. The fancy shirts cost $28 and the plain shirts cost $15. These 2 sentences right here create some mathematical statements. We can state that the fancy shirts are $28, and we'll know the total cost of those fancy shirts if we knew how many shirts that we're buying that are fancy. Plus those $15 plain shirts multiplied by the number of those plain shirts. Altogether, this should equal to $131 because that's how much Kristen spent on shirts in total. So this part here is the cost of fancy shirts and here this is the cost of plain shirts, and this is your total. So that's where that equation's coming from. Then another one said if she bought a total of 7, then how many of each kind did she buy? So we know she bought 7 shirts in total. Well, we could add the number of fancy shirts and the number of plain shirts, and they should be 7 then, because that would be the total number of shirts. So now we have those 2 equations. I'm going to call this one star, and I'm going to call this one heart. Now, we need to rearrange one of them if we're going to use substitution. I'm just going to use substitution in this case. You are welcome to use elimination if you wanted to. I just think it's a bit more work. So I'm going to rewrite our heart equation a little bit because we already have X and Y with no coefficients in the front. So I can easily just solve for Y by subtracting X on both sides. Now what I can do is I can put heart into the star equation. So that means I'm going to replace the Y I see in star with 7 minus X. So this is our star equation, and instead of writing Y, I'm going to write 7 minus X instead. And this should be 131. Now we want to simplify and solve. So that means that I'm going to expand on that 15. So 15 times 7 is 105. And that 15 is going to affect the X as well. Now I'm going to collect my like terms. So 28 minus 15 is 23x. Sorry, is 13x. And then I'm going to move this 105 to the other side, which is 131 minus 105, and that's 26. Lastly, I'll divide both sides by 13. X is 2. Now we want to find y. So the equation for y was from star. Y is 7 minus x, but we know x is 2, so y is 5. Our final answer then, x is 2, which means there are 2 fancy shirts and 5 plain shirts. And that's it there. Let's try another one. There are 13 animals in a barn. Some are chickens and some are pigs. There are 40 legs in total. How many of each animal are there? First thing we're going to do is state our variables. So let's say x can be chickens and y can be pigs. And we're talking about the number of chickens and the number of pigs. Next thing we're going to do is create the 2 equations. There are 13 animals in the barn. That means if I combine the number of chickens and pigs together, it should be 13. So x plus y is 13. You can call this one star. Now it says there are 40 legs in all. So what we're going to do is try to state this in the number of legs of these animals. So we know a chicken has 2 legs. If I multiply it by the number of chickens there are, I'm going to get the number of legs from chickens. And pigs, they have 4 legs. And if I multiply it by the number of pigs, I'm going to have the number of legs from pigs. And it says there are 40 in all. I can call this one heart. So those are my 2 equations then. Our next step, we're going to rearrange one of them so that we can substitute into the other equation. Again, if you want to use elimination, you can. This one's a bit easier to do for elimination, but I'm just going to go ahead and do substitution here. So I'm going to rearrange star. And I'll move x to the other side. So it'll be 13 minus x. Now we're going to insert star into our other equation. So every time I see a y, I'm going to replace the y with 13 minus x. And then we're going to solve. So expanding this, 4 times 13 is 52. 4 times negative x is negative 4x. And then I'm going to rearrange this equation and solve for x. 2x minus 4x is negative 2x. 40 minus 52 is negative 12. Then we want to divide both sides by negative 2, so x is 6. Next thing we're going to do is find y. And from our equation of star, y is equal to 13 minus x. We just figured out what x is. It's 6. So 13 minus 6 is 7. Y is 7. Now we just need to state our final answer. X was the number of chickens. So we have 6 chickens. And y was the number of pigs. So we have 7 pigs. And that is your final answer. For the next 2 questions, I want you to try them on your own. So question 3 is very similar to question 2. And question 4, it's a little bit different, but it's basically the same sort of thing. You follow the same sort of steps. So try 3 and 4, and then when you're ready, press play to see the solution. So the third one, we have a farmhouse that's sheltering 10 animals. Some are pigs and some are ducks. Altogether, there are 36 legs. You want to know how many of each animal there are. So I just let x be the number of pigs and y be the number of ducks. And then I found my equation. So the total amount of animals is going to be the number of pigs plus the number of ducks, and it's supposed to be 10. Then if I look at the total legs, there are 4 legs on pigs, so that's where I got the 4x. And there's 2 legs on ducks, which is where the 2y comes from, and we need 36 in total. Then I rearranged the first equation, and I put that first equation into the second equation and solved. And in the end, I got 8 pigs and 2 ducks. For the other question, we were talking about vehicles. So there are 7 vehicles in total, but the 2 types are cars and buses. For the first equation, I just add up the number of cars and the number of buses, and in total we should have 7 of them. Then next, I looked at the total number of students. We know in total there's 195 students. We also know that each car holds 5 students and each bus holds 45 students. So for 5x, that comes from 5 people per car. And we don't know how many cars there are right now, so I left that as x. Then the 45 students can fit into a bus, and we don't know how many buses there are, which is where the 45y comes from. In total, this should have 195 students in a vehicle. Then I rearranged the first equation and put into the second equation, solved for it, and in the end I got 4 buses and 3 cars. We're going to do 2 more examples together, and these ones are a little bit different. So in this case, we're going to determine 2 integers such that the sum of the smaller number and twice the larger number is 46. Also, when the square of the smaller number is decreased by 3 times the larger, the result is 93. The first thing we want to do is create this system of equations. Don't try to get tripped up over these words. It sounds like there's a lot, but we do need to find our variables first. So there is a smaller number, and the other one we know about is there's some other large number. So let x be maybe the smaller number, and let y be the larger number. Now we're going to analyze this to see what those equations are going to be. The sum, that means we're going to add. So if we add up the smaller number and twice that larger number, in total we should get 46. So sum is adding. So if we add the small number, which is x, and twice the large number, which is y, we should get 46. That is our first equation. I'm going to call this one 1. Now I want to find the second equation. It says the square of the smaller number is decreased by 3 times the larger, and the result is 93. So the square, this means I'm going to square that number. X is my smaller number, I'm going to square it. Decreased is subtraction by 3 times the larger number. We should get 93. This is the second equation. Now that we have our 2 equations, we're going to solve for the system. We could do this using substitution or elimination. In this case, I am just going to use substitution. So I'm going to rearrange number 1 and solve for x. I'm going to move the 2y to the other side. So we have 46 minus 2y. Now I'm going to insert the one we just found in 1 into the second equation. So we have x squared, and we replace x with 46 minus 2y, all squared, minus 3y is equal to 93. Now I'm going to rearrange this a bit. We're going to have to square 46 minus 2y. In other words, this is 46 minus 2y times 46 minus 2y. That's 1,116 minus 184y plus 4y squared. This is just coming from 46 minus 2y times 46 minus 2y. I'll leave everything else alone. Now I'm just going to rearrange this equation so it looks like a quadratic. I'm going to combine my like terms and move everything to one side. So negative 84 minus 3y is negative 187y. 2,116 minus 93 is 2023. And just by looking at this, we're probably just going to use the quadratic formula to solve. All right, so my b is negative 187. That negative times negative becomes a positive. B squared minus 4a, which is 4, and c, which is 2023, all divided by 2a. You can use your calculator for this. So if you go ahead and evaluate this in total, you're going to get two numbers. One is 17 and the other one is 29.75. If you read the original question, we're talking about integers here. So this is not an integer because it has a decimal. We're not going to include this as part of our solution. Okay, so we know y is 17. The last thing we're going to do is find x. And we know that x is 46 minus 2y, and y was 17. So then x is going to be 12 after that calculation. So your final answer is x is 12. Y is 17. Your larger number is 17, your smaller number is 12. One more question we're going to do together. We've been given the path of a ball thrown by Luke and it's modeled by this equation. D is the horizontal distance from the ball to the center of the hoop in meters, and h is the height of the ball above the floor. We're also given the path of Ben's jump, and this could be modeled by this equation, where D is the horizontal distance from the center of the hoop in meters, and h is the height of his hand above the floor in meters. It says solve the system of equations algebraically. So I'm just going to write down our two equations again. And because I've been doing so much substitution, I'm going to do this with elimination now. So if I want to use elimination, I have to figure out which one I want to remove, either the D or the H. In this case, we probably want to remove the H because we have a D squared and a D. And if I only get rid of the D squared or the D, I'm still left with two variables, which doesn't help me at all. So I'm going to remove the H. And I'll do this by multiplying our second equation by 3 so that I can get 3h in both equations. So I'm also going to number my equations. So we're going to multiply equation 2 by 3. so we can remove h. Now I'm going to align this into vertical subtraction. And also multiply 3 to my second equation as I write this in by multiplying by 3. So 3 times 5 is 15, d squared. 3 times negative 10 is negative 30, d. 3 times h is 3h, and then 3 times 0 is 0. Now we're going to go ahead and subtract this. D squared minus 15d squared is negative 14d squared. Negative 2d minus minus, which becomes plus 30d, is going to be 28d. 3h minus 3h is just 0, and then 9 minus 0 is 9. So this is what we're left over. Now I'm going to rearrange and solve. So I'll move the 9 over. And this is a quadratic equation. We are going to use our quadratic equation, quadratic formula, to solve for it. So d is then equal to negative 28, which is our b, plus or minus the root of 28 squared minus 4a, which is negative 14, and c, which is negative 9. All divided by 2 times a, which is negative 14. Just going to go ahead and simplify and solve for this. So our two answers from our quadratic equation formula is going to be 0.402 and 1.598. That is our d value. We need to solve for h as well. So for h, we can just rearrange equation 2, and h would be 10d minus 5d squared. And then we're going to plug in our d. So our first one is going to be 3.214. And then we can do it again before 1.598. And we're going to get the same value. So our final answer then is d is 0.402, 1.598 meters, and h is always going to be 3.214 meters. In part B, we just want to interpret our results. So we found that d, which is our horizontal distance from the center of the hoop, is 0.402 meters. And at that, we're going to achieve a height of 3.214 meters. Or you could also have a horizontal distance of 1.598 meters, and you will achieve a height of 3.214 meters. So the assumption that we are making is that these two equations would intersect each other. And in this context, that means the path of the ball thrown by Luke and the path of Ben's jump will yield the same height and the same horizontal distance at some place. And you can think about this even by just graphing these two equations and finding their intersection. And that's what that would mean. That's when those paths are going to cross each other. So the path of the ball thrown by Luke and the path of Ben's jump will yield the same height and horizontal distance at some place.